film covers the cold reducing and warehouse units of Timken Alloy Steel Europe Limited. This unit takes hot finish tubes from the hot mill as its raw material and reduces their size by the cold pildering technique. This results in a range of smaller sizes from 18 to 127 mm in diameter. Cold finish tubes also have a better surface finish, closer tolerances, better concentricity and improved machinability. The first operation is to put a chamfer on the leading edge of the hot rolled tube to ensure clean entry to the cold reducing machine. This is done on a lathe known as the rounder. These hot rolled tubes are ready to be loaded to a cold reducing machine. 13 cold reducing machines are available, sourced from different makers but all of the same basic design. Each machine is capable of producing a specific size range. Work is planned through the department in such a way that some machines are in operation while others are being set up for the next order. At the heart of each machine is a reciprocating saddle. This houses a pair of semicircular taper-grooved dies. These compress the diameter and walls of the incoming tube into a tapered mandrel, which is positioned in the bore. The mandrels are available in a range of sizes and are chrome-plated for wear resistance. Each pair of dies has matching tapered grooves. These are selected to suit the reduction of area required. The profile of the grooves has a working section and an ironing section to produce a round tube of good surface finish. The dies fit into pockets in 2 rolls, mounted vertically above each other in the saddle. These are geared together to rotate in opposite directions. This view of the dies mounted in the saddle shows the pass profile seen by the tube during each forward movement. The rolls are geared to impart a rocking motion to the 2 dies, which rotate 180 degrees during each forward movement of the saddle. In combination with the mandrel bar, this movement of the saddle forms a short length of finished tube. Before the next stroke of the saddle, the tube is fed forward a short distance. It is also rotated through 60 degrees to ensure uniform cold working over the cross-section. Looking at the inlet side, the short forward movement can be seen. The crosshead moves forward on a feed screw, synchronised with the rocking motion of the dies via a feed and turn gearbox. The mandrel is supported on a bar which passes through the crosshead and along the length of the tube. On the outlet side, the finished tube is seen emerging from the saddle. The belt drive from the motor can also be seen. The motor and most of the drive mechanism are hidden underneath the machine, but the crankshaft is seen exposed here. Vertical sliding balance weights under the machine ensure smooth operation. A dedicated machine shop within the coal business unit handles machining and reconditioning of dies and mandrels. Facilities include profile grinding, heat treatment and chrome plating. When batches of tubes leave the cold reducing machines, they go through a number of finishing and inspection operations. The first of these is straightening, using a 2-roll rotary straightener. Some material is sent for heat treatment in a Berleck furnace before straightening. On exit from the straightener, the batch is transferred by crane to the inspection and cutting operations. The first of these is ultrasonic testing, where one of 4 machines checks for bore defects resulting from the cold working. The wall thickness is also measured during the testing. Results are monitored on screen and the data is stored for future reference. Tubes are cut to length using a Riker lathe. This is computer controlled to cut the optimum lengths within the range specified by the customer. Precision cutting and chamfering is ensured by the use of a profiled cutting tool. After cutting, tubes are passed through an automatic inspection unit. This cleans the outside surface, measures the diameter with a laser gauge and checks for obstructions in the bore, such as broken mandrels. It also checks for defects in the outside diameter using eddy current testing. Finally, it checks the material type and line marks each tube with the customer's identification marks. At this point, tubes are transferred to the warehouse. Some material is given a rust prevention treatment before being laid out for final checks prior to dispatch. Tubes are strapped and labelled in bundles for ease of transport, storage and customer use. A final check is made on the material type by the technique of spark testing. The end of each tube is tested with a hand grinder. Training and experience enable a spark tester to identify incorrect material by watching the pattern and colour of the sparks. Bundled material is then stored in racks to await transport to the customer.